Ready? All right, so my name is Chris Carmelo. I work for Purity Laboratories, with a water treatment company that is subcontracted through North Shore Climate Control to do the treatment of the heating system and the chill water system for the 1 year of warranty period until the house water treatment company takes over, which Syntec is now sort of taking care of and overwatching this. We'll start with, this is the heating system. It's uniform across both systems. It's the same thing here. Sorry, hit the microphone. It's the same thing I'm going to do on this system that you'd be doing on chill water. So I'm just going to demonstrate on this system, and it just carries over. So we'll start with the filter feeder. It's a 5-gallon filter feeder. It's a side stream flow assembly. So what happens is it comes off the supply side or discharge side of the pump. It goes to the canister and then gets deposited back in the suction side, the low pressure side. That we have positive flow through the whole canister at all times. In order to, this is where you would be using to dose the system with chemical. If for whatever reason it loses its water, if there's a leak, if there's a repair, for whatever reason, if you got to flush it out, you got to redose it with chemical, this is where you're going to be doing that. To use this to dose the system, what you have to do is you have to locate the isolating valves to and from it. So what we have, bottom of the tank, we have one valve here. Slowly close it. Never close the valve all at once, because then you have what we call water hammer, and that's 7 times the standing pressure, and it could blow out a valve or blow out an elbow or some weak component. Supply, shut that slowly. Now we have it being bypassed through this coupon rack, and this is now free to open. So once it's open, you got to find the drain valve on the bottom. Always relieve the pressure before trying to open it, or else this canister is pressurized, and if you try to open it up while it's pressurized, you can burn your legs, your midsection, or you can have pressure blow up and get you in your face. So we don't want that. So relieve the pressure. This is very nicely piped to the drain, so you don't have to worry about running a hose. A lot of times you have to put a hose fitting right to the drain. Then once it's depressurized, you got to use a wrench or something just to sort of loosen the gasket and ring on this threaded cap right here. So if you can, I'm going to use this as a little heat barrier, because it is very hot. Just a slight tap. Once it's open, you remove the cap like that. You can use a camera on your phone or whatever and just watch the water level go down as it's draining to the drain over there. Then you shut it. Once you have the desired amount of water out of the canister, then you then take your treatment, and then you take this is a powdered, so you take it and you just put it right in here. Always leave a little bit of water so it can dissolve itself. And as you want to refill this tank, you want to fill it up with as much water to get as much air out as possible. So what we'll do, we'll take the low pressure side, which is going into the bottom. That way we don't spray ourselves in the face with this water that comes up. And we'll fill this up. You'll start seeing the water rise slowly. I know it's a little hard to see, but if you can see, we're filling this whole canister with water. A little bit of air is okay. We have an air separator, luckily. But even then, you could create a situation where this canister can become airbound, and then it doesn't push any chemical through, and the next time you try to open it, gas. So then, to put the cap back on, you want to make sure this gasket is all the way sealed around and didn't get stuck to this and peel out. Because once you try to seal it back, if the gasket's not set in place right, it'll leak down the whole canister. Put this on top. Find the threading. Tighten it, and just hand tighten. Never use a wrench. It's hot, so gloves are probably a good idea. So that once it's sealed tight, open these slowly to pressurize the canister. Establish flow, and you can open it up again. Same thing with the coupon rack. Coupon racks are dissimilar pieces of metal. that are used in order to calculate corrosion rates over the period of 90 days typically. What you do is you would shut this, grab a pipe wrench, take out these little coupon holders. Inside you have a little piece of metal. Take that off, send it to a lab after it's been circulating for 90 days, and they'll send you the results back with how much weight of the metal has been lost over the period of 90 days. And that'll sort of give you an idea of, it looks like they're already following this right here, so Syntec's taking care of that for you guys. Then we'll pull a sample. Pulling a sample is very simple. It's good to take it from the bottom of the pump, preferably a circulating pump, so we're going to go over to that one, if you don't mind. Just give me 1 second. Sorry. Go right here. There's a suction side of the pumps where we're pulling from is where the bottom of the strainer is. This strainer naturally captures a lot of debris, so your first couple samples might have some stuff in it that you want to flush out. Fill it up, dump it out. Fill it up, dump it out. All right. Fill it up. Once you have enough water that you can sort of play with, always return the caps. I'm coming over here now. Just going to sort of reset up right here. Once you have your sample, let me know when you're ready. Once you have your sample, find a spot where you can sort of make a mess on the floor. And we're going to start with this. This is a conductivity pen. The conductivity just measures a very vague reading of total dissolved solids in the water. So this gives you, this could be particulates from the city water, addition of chemical, could be in a chill water system in particular, could be an issue with bacteria, which we call sulfate reducing bacteria. That's what creates the foam in the water and that nasty smell. If you've ever come across it, you can never forget that smell. This is our first line of defense or understanding of what might be happening within the system. So we're looking for a number probably between 1,000 and 3,000. It's like a broad range. What we're trying to determine is if it is saturated with chemical or if it's losing water. So what you do is you find like a kitchen sink or a bathroom sink or anything, test your sink that's coming into the building, and that gives you your baseline, and you can compare from there. So what we'll do, you take your cap, remove the cap from here. I always fill and dump twice. That way, I eliminate cross-contamination between sampling and systems. So on the pen, we hit on. It's going to read a little number, 00. Place the cap in there like so. And then it has to adjust for the temperature. So as the temperature is cooling down, this probe is reading it, the number is going to climb, it's going to drop down. And when this number stops dropping, then we have the accurate representation of conductivity. So in the meantime, what I like to do is just put this to the side. While that's accounting for the temperature, I then continue my next tests. Here's a service report. On here is where I'm going to be logging the information. And then we can determine, we could have like control values there so you can sort of judge whether it's within the range or without the range. And let's see. All right, so this is, looks like it's slowing down pretty good right now. So we'll hit hold. We're at 3,770. So it's blinking times 10, like only show 3 numbers, so we got 3,770. With this particular chemical, nitrite, it's good to have an overabundance of it. You can't over-treat the system with nitrite. Especially the powder boosts the conductivity significantly, which is what they're using. And so 3,770 that's a perfect number. So what I'll do, you have that pen again? Oh, look at that. Thank you. All right, so we have conductivity. I log it there, 3,770, done. And move on. Go to pH. pH is just another indicator of what could be going on within the system. The pH is between 8.5 and 11, say. Usually between 9 and 11 is a good range. The lower the pH that you find, the first sign of the first thing that indicates is a loss of system water and a replenishment of fresh water. So that city water that's coming in is now neutralizing the chemical. Chemical's going down through a leak somewhere in the system, and that it's constantly making up, dropping the pH, dropping the conductivity, dropping the alkalinity, and dropping the chemical levels that we're going to be testing for. So you'll sort of see a trend as these numbers go down. Start wondering, okay, what's going on? Did we do any repairs? Is there a repair currently going on? They have to drain the system. They find something, or is there someone kick a valve open over the weekend, or something where system water is being replaced? And that's a big issue. It's very common. So we'll take our little test tube. Test tube goes to 5 milliliters. We're going to fill this up. I always fill up and dump it out a couple times, like I said. Fill it, dump it. And we're going to fill to the 5 milliliter mark. If you go over, it's totally fine. If you go over the 5, all you do is just flick. Just like that. Now we're exactly at the 5. Once you're at the 5, take your long range indicator. We'll do 5 drops for 5 milliliters. Straight up and down. There we go. 1, 2, 3, 4, 5. They say put this cap on and mix it, but I've found that every time you do that, a little bit of water drips out the side. Not that it really matters. If you use your fingers, sometimes the oils on your fingers can drop the pH and skew the results, but they say that. I've never noticed it. I've never seen much of a difference from your finger being on top of it to actually change the color of the test. So once you have that, you find a light source above you. You sort of just gotta make your best judgment of where in the range this looks like. If you see a slight bit of gray, like fresh water will be very yellow, almost clear. As it goes up a little bit with more particulates, and the harder the water, the more chemical used, it'll slowly climb up through the pH range. You start seeing, so this looks like probably right on the money with 11. But with my understanding of sodium nitrite, pH is probably between 10.5 and 11. Very, very rarely do we see it go any higher than that. So we'll just split the difference, say 10.7. If you have a pH reader that's like a probe or conductivity store, like my conductivity pen, you may have one upstairs for the cooling tower. If you want to, which Syntec's taking care of it, so you guys are sort of out of your hands. If you wanted to, you can cross-reference the different test kits to just make sure. I always do two. I have pH strips and pH strips, and I do both of them every time just to sort of split the difference between what I think is the most accurate number. I also have the long-range indicator and my own test kit, so I have 3 different pH tests that I can determine if one of them is just maybe a little off or the strip's a little old or something. I don't know. Sort of helps me. So that's pH. So we'll take 10.7. Put your little pen. pH 10.7. All right, next is the actual inhibitor, nitrite. It's a nitrite can solution test. What this is going to tell us is how much chemical is actually in the system that can be used to help scavenge the oxygen. So, what this particular chemical does, nitrite, is hungry for an oxygen molecule. So in that H2O, it immediately takes that O off of the H2O and it puts it into to its nitrate molecule. So then it starves the water of its oxygen, preventing it from being able to oxidize the iron, which it's so hungry for, which is oxidation, iron oxide, which is just rust. So it slows down, it slows down the corrosion rate significantly. Nothing stops it for good. We can only slow it down to almost a complete stop. This one in particular, we're only filling up to 5 milliliters, not 25. Here we have 5 milliliters, you gotta just make your best judgment. If it's below, you need to, it can be slightly above 5, can't be below, because you're already working on such a small amount of water. So once you have your 5 milliliters, you're gonna go to your second one, which is your Fairwind indicator. You're only gonna do 4 drops of this. 1, 2, 3, 4. Turn the cap. You're going to come over to your next one. These two are the same. The reason you have more of these than this is because you're going to be using a lot more of this than this, if the system has chemical in it. So now we're going to, our can solution, we're going to do 1 drop at a time, swirling this one slowly, or swirling it slow or fast, doesn't really matter. 1 drop at a time until this goes from red to blue. I like to hold this straight up and down. The reason it's important to hold it straight up and down is that if you have it slightly cocked to the side, a different size drop comes out, and then it could be a slightly skewed result. So we'll go straight up and down. Counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I always stop at 20 if it's above, and then I would just do the little math. What we're doing is multiplying every drop by 40, so 20 times 40 is 800. We're now at 800 parts per million of sodium nitrate within the system. It's an excellent number. Can only be better going up. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. We're at 30, which is 1200 ppm. Perfect. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I would stop at 40. That's 1600. Our recommended range between 400 and 1500. Could be more. Some places want between 1000 and 2000. It's still effective at a range of 400 ppm. Just so you can see the color change, I'll keep going. So we're at 1600. What I would do on my number, on my service report, I would write 1500 plus because it's above the recommended range. At that point, it's fully protected. There's no risk of corrosion there. So it doesn't even matter to keep testing, unless you really want to know exactly what it was. 1600, we'll keep going. 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Start seeing it change. And that goes to pretty blue. That's it. That's 50 drops. So that's exactly 2000 ppm. Take your sample, dump it out. I always just rinse it out so we don't have the reagents from the previous test. And if you're moving from system to system, you're going to be rinsing this out anyways with the system water. So once you're done with that, you can dump your sample. Always return these. Now if that gets lost on you, this one in particular has the steps written out very simply to explain how to do it. Everything I just explained. Right inside, and you return the cap, like so. pH, conductivity. I didn't see a conductivity pen over there. Should have been one of them. It looks like that. Same thing. Again, we'll do here. 2000. And then you would log that in a logbook. That's all the test kits. That's how to use the filter feeder, how the coupon rack works. You guys have any questions? I think that concludes the training for the test kits and the bypass feeders and coupon rack for South Beach Psych, 777 Seaview Avenue. My name is Chris Carmelo, Purity Labs. Thank you so much.